This is the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. This podcast series is sponsored by Allied Electronics and Automation, carrying the most automation and control brand names in North America. Now, the questions posed in this podcast series all come from automation technology users across the process and discrete manufacturing industries. I'm David Greenfield, Director of Content for Automation World, and the topic for this podcast is, what are the pros and cons of smart instruments considering industrial security concerns? Now, joining me for part one of this podcast is Dr. Helge Hornis, Regional Technical Director of the Americas for Pepperl+Fuchs, a supplier of sensors, intrinsic safety, and explosion protection technologies. So, Helge, before we get into the details around smart instruments, cybersecurity issues and such, let's kind of start off just by explaining what exactly smart instruments are and how they differ from traditional industrial instruments.
So at Pepperl+Fuchs, we draw the line roughly like this. A conventional instrument is a piece of equipment that provides only the data point that it's designed to do. So for instance, a proximity sensor would tell you that there is a target or there is no target, or a pressure transducer would provide you with the value of the pressure, and a distance measurement sensor would tell you how far an object is from the sensor that needs to be measured. So it focuses on its main function. The difference between that and a smart device is that the smart device goes way beyond that. It has additional information, additional data points that are not really at the core of the product, but that add additional value and benefits to the user. So for instance, a photoelectric sensor could provide a temperature reading. Now, in and by itself, that may not really have that much value, but if you have temperature readings from all your instrumentation, then you can gain insights into what is going on at the system, and are there some fault cases, or is just the sensor hot, or is the machine hot, so you can gain other benefits. That's a simple case. Another scenario has to deal with preventive maintenance, and let me give you another example for that. Imagine a process valve that is driven open and closed via some sort of actuator. And if you now measure the stroke length of that closing and opening action, you would be able to determine when the seat of the valve is getting worn, mainly because suddenly that valve can just push a fraction of a millimeter or a millimeter deeper. So you can get additional pieces of information that are useful for the diagnostics, for the maintenance, and for the operation, but is in addition to its main function. And these types of scenarios can be thought about across essentially all pieces of equipment you can imagine. They're different from case to case, but that's the general idea behind smart instrumentation, or one of the ideas.
Okay. So talking about this extra data points that you're mentioning that are, really are what define the smart instruments, is there common sets of these data points for different types of sensors that they typically provide? I mean, in certain types of sensors, what will be considered a smart instrument, it has these additional types of function, or does those additional new data sets or data points of information, do those differ from technology supplier to technology supplier?
Yeah, they definitely differ. Okay. The core technology will have an impact on the specifics of this additional information. That's one. And then secondly, it's also how far forward-looking a supplier would be to identify what is a valuable additional data point for the user.
Right, and speaking of that, we're talking about these additional data points of information, how they can differ from supplier to supplier. But is this also the case with any type of smart instrument, whether it's a sensor or an actuator? Will they all have these additional data points being the characterizational difference between a traditional and a smart instrument, or is this specific to certain types of instruments that tend to have these additional points of information?
So I can speak much better for the factory automation world where I am at home, but I have some knowledge of process. So let me talk for factory automation. In factory automation, there is a very strong trend to higher level, higher intelligence products. And at the core of many factory automation systems is the inductive sensor. It's a tried and true, ultimately very simple product that detects a piece of metal for presence. And now with technology being where it is, you will find that these products, even these simple products, will get additional data points. But the specifics of it is again up to the manufacturer. But what is clear is that as time goes on, more and more additional pieces of information are going to be processed and are going to be made available by more or less everything, down to the simplest sensor, the inductive sensor in the market.
Okay. All right. Thanks for explaining that. One other question here while we're on these core issues about smart instruments. I know these instruments now have been out for several years. It's not exactly a new technology at this point, but how mature would you say this smart instrument technology is? Is it still really new and developing, or would you consider it fairly mature at this point in the game?
All right. You're absolutely right with your initial statement. There's not a single technology in this whole sphere of IoT or Industry 4.0 that wasn't available a few years ago. What is truly the new quality is that someone realized, or a group of people realized, that by combining all these core technologies, there is significant additional value in a machine, in a plant to be obtained. So is it revolutionary? Only in the sense that it is now viewed as being something that's all inclusive. So having said that, getting to the specifics of the technology, most of this stuff is actually very much established. Okay, Ethernet communication, which is at the heart of many of these devices, has been in the office space for a long time, even in the plant for a long time. So we're utilizing tried and true and very well established technologies. If I then go further into the field to the end device, there's a technology called IO-Link that allows even the most simple and most basic sensor to communicate vast amount of information. That technology, while very much at the forefront of the conversation right now, is certainly nothing that was invented in 2016 or 2017. It's been out there for a long time. Speaking for Pepperl+Fuchs, we have had these types of products for going on 10 years, and initially, when there was less of a market interest in it, we used this interface, this communication interface, for internal purposes, configuration and data exchange that we needed in our manufacturing process. So the market is already very much penetrated by these intelligent products, and so the users are now in a position to utilize this because all the missing components around it are being made available by a number of companies.
Okay, so considering that it's a fairly mature market, as you described there, but yet, as we were discussing earlier, there's still so much differentiation between the different types of instruments based on who's supplying it. Are there any pieces of advice you would have for users who are looking to buy, which could be any type, it could be an array of different types of these smart instruments they might be looking to install, but is there a baseline for specific functionalities they should be looking for from this, or is that too much of an it depends kind of question based on what they're doing with it?
Yeah, I believe it depends, but there's one thing as a general rule that I think I would say is true. Any automation system that's going to be put in 2019 has a high likelihood of having to operate in 10 or 15 years. These systems tend to be in operation for a very, very long time. And therefore, the engineers that are working on those solutions need to think about the possible of tomorrow and the day after tomorrow. Okay, what may happen in 5 years? This is a hard problem, but it's very critical to think about where this whole thing could possibly go. So rather err on the side of caution, meaning put a little bit of extra stuff, a little bit of extra capability in today, it will pay off in the long run. And rather than having to throw out end devices, and end devices are probably the most critical piece because they are highly integrated with the machine. They are frequently hard to get at. Make sure those are really the latest, the greatest technology available. And if someone doesn't yet use all these fancy new things with like IO Link on IO blocks and Ethernet connections into the cloud, that's okay. That is much easier to swap out if you don't want to go all the way right now. But on the sensor end, it's probably good advice to be very, very much forward-looking.
Okay. All right. Thanks for clarifying that. All right. So now that I think we've got a good base on what a smart instrument is and what differentiates it from a traditional instrument and what all of those facets mean, let's go into kind of the core of this question, which was about, since these are connected devices, they are connected, online, so they can be accessed and the data either sent, to upper level systems or viewed from remote locations. What are the key areas of concern around cybersecurity when you're talking about field level devices at such a low level like a smart instrument?
That's an excellent question, and the market or the answers to that question are still evolving. What is clear is that if you don't mind, I would rather come from the top end, and the top end will ultimately be some sort of an Ethernet connection to somewhere. The Ethernet connection could be an Ethernet connection that remains within a plant, or it could be an Ethernet connection that by some IT methodology goes out into a truly cloud-based system. So Industry 4.0 does not necessarily mean things have to be in the cloud. What Industry 4.0 really advertises is to utilize these IT technologies, and they can be somewhat islands, where an island could be an entire plant or a corporation via some VPN, some virtual private network. But it is not absolutely necessary to go into the cloud. So having said that, the strong IT measures that are put in place for corporate computing systems need to be available on these devices. I think that's an absolute clear first step. The additional steps that need to be taken by the manufacturers are centered around authentication as well. So communicating devices need to authenticate each other so that when a controller talks to a field device, it can be certain that the information is not a fake from someone else injecting himself or itself into that communication scheme. And there are technologies available to doing that, including hardware, very, very, very strict hardware technologies like trusted platform chips and so forth that are part of hardware designs. Not too many devices utilize that as of now, but I believe that in the medium term, that's where the market will be going. So that they're designed, hardened, on top of having state-of-the-art IT methods like firewalls. But that's not enough. Just a firewall is not going to be enough in the long run.
Are there, considering that, this sort of level of cybersecurity we're talking about, as you mentioned, needs to be built in and specified and designed in by the manufacturer, Is there a core set of capabilities around cybersecurity at this level that end users looking to buy these technologies should be looking for or making sure they're a part of that technology that they're buying?
Right now, I can tell you from my experience that the users deal with this problem by internally isolating their systems. So the availability of products that has this level of security is essentially zero. There may be a few exceptions, of course, but as a whole, it is not there yet. This is very much evolving. This part is very much evolving, and so the easy way or the best way to deal with it is to have some level of isolation. And in general, I would always suggest talk to your supplier how they view it. What are their methods? So I give you an example. Via Neoception, we have a system that is in a plant. It happens to be an RFID system that communicates with an IoT gateway. And one of the immediate security features is that it is impossible to come in from the outside and communicate with this device, in a sense that you cannot open this connection. The connection has to be opened from the inside out. So that's one thing. So if you think about it in terms of a phone call, you are calling your bank, and therefore you know who you're calling. The bank is not calling you. Because anybody could claim to be the bank. So that's one thing. Now, on top of that, there are, of course, other methods that are part of this communication structure that will make sure that everything is correct. But this is one of the principal measures that is applied for cybersecurity. Make sure that it's clear who is calling and who is making the connections.
Okay. And how would that would that be something that would be an IT level security system there that's securing that's part of the the whole operation, or is that something specific to the shop floor?
Well, in this scenario I just gave you, it is a specific feature of the implementation of a piece of hardware that's part of this IoT solution.
Okay.
So this IoT controller simply will not allow incoming connection requests. It's like someone calls you and you never pick up the phone. That's how you need to view this. It's only going one way.
Okay, I see. So it's inherent in the controller itself.
Yes.
That's doing it. I got it.
Yeah.
And just to clarify, you were talking early on, you said a key aspect of this is that the system should be isolated to some degree. And obviously we know full air gap systems, there's lots of arguments if they ever really existed, but it's even more difficult now, especially with all the smart devices out there and the increasing connectivity of plant floor systems of all type. Can you clarify a little bit about what you mean by isolation of these devices and how that would be affected?
Yeah, certainly. So I'm not saying that they should be, because when you isolate a system, then you give up functionality. Think of it, if you roll the clock back 25 years before the internet came out, and you had a PC at home. That PC was completely isolated. The notion of a virus was virtually unknown because you hardly could get it unless you had illegally obtained software. But just look at how much more valuable that computer now is because it's connected. So clearly we need to get there. What I was trying to say is that today as in really right now, most systems are not that heavily interconnected. They tend to be set up isolated. That means that the shop floor may have a private Ethernet network. And there may actually be a point where limited data can leave the shop floor and go to accounting, or may go to quality control. That may be the case, but for the most part, a large number of systems is still built in this isolated fashion, and that gets around certain problems, absolutely correct. On the other hand, you just don't get the gains that IoT and Industry 4.0 promises. So that's why I'm saying one needs to tackle this problem, and the products that I suggest people buy right now don't inhibit this advantage to be utilized at the low end, so that in the medium term, a few key components can be swapped out, so that all the benefits of the sensor level intelligence can be utilized, and it can be done safely in a much more interconnected way.
Okay. All right. Is there any other tips you'd have about beyond what we discussed? I mean, it's been a very thorough discussion here, but what any other tips about generally approaching this, since we're obviously not getting specific to specific types of instruments and applications, but at this general level, any other tips about approaching the cybersecurity aspects of this to make sure you're dotting the I's and crossing the T's as much as possible?
Yeah, clearly cybersecurity is a very tough field. Mm-hmm. And I wouldn't consider myself an expert in it at all. I would propose, I suggest that customers or users think this through with their IT staff and ask the tough questions. How someone that is supposed to build a system for them, how they want to assure that nobody gets in, and that the data is all valid, and that they don't run into these systems into these scenarios that you can now read about, where cybersecurity hacks take over printers and make the printer the attacker within a network. So this is kind of the worst case scenario, when someone takes over a piece of hardware and turns it into a slave for a cyber attack. Mm-hmm. And these questions should be asked.
Okay. All right. Well, thank you for joining me for this podcast, and thank you to all our listeners. Please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.